So this is chemical reaction 7. We're going to talk about catalysts today. Resume video recording. Alright, so a catalyst, a lot of times we think about, I'm going to switch my marker here. We think about catalysts, we think about mini golf. And you might say, well, what on earth? And okay, well, it's not a callus. Let's read the word catalyst, like a catapult. A catalyst is something that changes the rate of the reaction. Of reaction. But before we can really think about a catalyst, we have to think about activation energy. Now, we've talked about this enough that you might have a definition in your head already. But activation energy is the minimum amount of energy, obviously, to make a reaction go. To make a reaction go. And a lot of times when we think about activation energy, we look at a graph. Looks something like this. Energy on one side, the reaction on the other, and then we have this hill. Okay. What do we start a reaction with? What are those things called on the left side? Reactants are on this side. Products are what we end up with, what we produce from the reaction. Okay. So this hill right here is the activation energy hill. Okay, so I said earlier, sometimes we think about mini golf. Have you guys ever played mini golf?
Oh, yeah.
Okay, so we have this little golf ball right here, and you have a club of some nature. You have to hit that ball over the hill to get to the hole that you're trying to get to. Is it harder to hit the ball over a hill than to hit it in a straight line? Yeah, that's one of the parts of mini golf that makes it fun. Because you have to figure out how exactly am I going to meet all these obstacles. And so this activation energy hill is what's getting the reactants to the products. We need this much energy to make it happen. Okay. There's a couple other things about this that we want to point out. Okay. When our little mini golf ball, when our reactants get to this point right here, this has a special name. Okay. This is called transition state. So at the transition state, a reaction might go. It might happen. So the ball could, our reactants could go over the hill towards the products, or it could roll back. Have you ever played mini golf and it comes back at you from the hill?
Yeah, I'm usually pretty good at it.
Wow.
I usually do the
That's good. But our reactants could go back and stay reactants, or they could go forward and stay and become products. So that is that transition state is right there before we know if the reaction is going to happen or not. Okay? All right, so that's the first part. Another here's a definition that we're just going to kind of throw in there. The activated complex is between reactants and products. So they're not quite still reactants, and they're not quite products yet. So it's a transition state. It's at that transition. Okay. So here at the activated complex is that transition state when we could have products or they could stay reactants. So what do we need to actually make sure the reaction happens? To react, molecules must do three things. Number one, they gotta collide. They have to run into each other. They actually have to make contact. That makes sense. Because if they're going to synthesize something new, they have to run into each other. They have to be at the right angle. Or best angle. And they have to have enough energy. Okay. Now, that's all great for reactions in the lab when we're just watching them, but what about those reactions that actually happen in the real world, like in your body? Digestion, you guys all know about chemicals in your brain that keep us on a steady. We can't always wait for those things to happen, so sometimes we need to increase the reaction. Sometimes we are impatient, and that is just true. So sometimes we need to increase the reaction rate. First, we could have more reactants. Okay, so if I just flood the system, all right, then I have all of these reactants. They're going to run into each other more often. So it's more probable that the reaction is going to happen. 2, I could increase surface area for reactions to happen. A lot of times I could increase temperature or add energy. But the last one that we're going to talk about is a catalyst. And that's where this whole lesson is titled. Changes the reaction rate without being consumed. Your body has a lot of catalysts because, like I said, we can't wait on reactions to happen and just hope that they do. That doesn't facilitate life. The catalysts inside your body are called enzymes. Give me a thumbs up if you've heard of enzymes before. Okay, so we know this word. This is not new. For instance, there is an enzyme called lactase. Lactase breaks down milk sugar. Without lactase, your body can't break down milk sugar. So, no lactase equals lactose intolerant. You guys know, raise your hand or give me a thumbs up if you know somebody who's lactose intolerant. Like they can't eat ice cream. Probably some people in the room are. What did you say?
I usually don't talk to people like that.
Right, okay. Lactose intolerant. I honestly feel bad for them. They can't eat ice cream. But thinking about this chemistry, now we're talking about a catalyst. This is something that is very important in your body. This is one of the reasons we have chemistry in school, for you to kind of understand those things that are happening in a scientific way. All right, so that's really the notes that you needed for catalyst.